This is the Moon Rubik's Cube. It's a 3x3 cube that has the surface of the moon instead of any colored or textured tiles or stickers or anything like that. So I had this idea sometime in high school to combine a Rubik's Cube with the moon. And I thought that maybe you could 3D print these pieces so that they would have this the texture of the surface of the moon with a 3D printed cube. And so I tried to find what I did was I found a 3D model of a Rubik's Cube and a 3D model of the moon, combined them, and attempted to print it. But the 3D model of the cube that I'd found was not very good, and it was very loose and just didn't work right. So that was unsuccessful. A couple years later, I came back to the idea, and I realized, well, I don't need to use a 3D printed internal part of the cube. I can use an existing cube and put the moon 3D printed pieces on top of that. And this is the result here. It's on top of a rhombic dodecahedron, 3x3 basically. And so I 3D printed these moon pieces from that 3D model of the moon that I found online and glued them on as caps to this other puzzle that I basically took the stickers off of. And this worked out quite well. It's kind of catchy, but and it's a little bit, you can see it's a little bit messy where the pieces are kind of misaligned, and there's some problems with the heights of some of the center pieces not quite lining up, but you get the idea. It's the moon, and as far as I know, this is the very first time that somebody has done this, is this puzzle right here with the moon as its surface. So that's with that internal part that's not 3D printed, with the 3D printed kind of tiles on top, basically. I was also able to do this with Bennu, and I decided to make a Bennu cube because I had gotten a second rhombic dodecahedron 3x3. And this one actually started out being way more sticky than the Moon Cube. It was like almost impossible to use, but eventually it got a little bit better. As you can see, I've played with it for a while, and so it's gotten a little bit better to turn. But you know, I didn't want to be dependent on these just the model that I could find online. I wanted to be able to really make my own thing with it. Especially because I didn't want to use any of the models that I could find online of Mars, because I think they all look kind of silly, the way that some of the very extreme terrain features get exaggerated. I couldn't find any models of Mars online that I really liked, so I really wanted to be able to make my own. And so a few years later, still, I had learned enough coding to make my own moon model with a script that takes in a texture image that is a height map, basically, and then it wraps that around the sphere. It goes around the sphere and places the points to create an object file. Initially, I did that in MATLAB, and then later on I switched it to Python, because Python is free and MATLAB is not. And by that time, I also happened to have learned how to design my own internal mechanisms for twisty puzzles as well, for other reasons. And so I decided to come back to this, and I could go all the way back to the original idea and have the whole interior of the cube 3D printed with my own mechanism, and the exterior with my own model, so I can make it as nice as I want it to be, basically. And this is the result of that. This is the new version of the Moon Cube, and I chose to use about 2¼ scale on the terrain exaggeration for this moon. I think that provides a nice balance between being able to actually see the surface features, and they look really nice in kind of harsh, direct lighting as well. And you also kind of, it feels like the natural look of the moon as you're looking at it through a telescope or something. You can still feel the kind of the Aitken Basin pretty well, the boundary of it, but it's not as extreme like on this one. If you roll the cube around, it's just going to come to rest on that basin really quickly. Of course, since it does roll around a little bit, I also made a little stand for it. I think this stand looks pretty cool. You can do it two ways. You can do it kind of with the parabola facing the moon or facing down towards the ground. I like to have the stand with the parabola facing towards the moon because this means that the little leg of the stand actually follows a trajectory that you would follow if you launched a rocket in the moon's gravity. It would make a parabolic trajectory, just kind of like that. So these are three ballistic trajectories off of the moon there. Now, solving this, a lot of people, they see this and they ask me immediately, well, how do you know when it's solved? Well, you just have to know where everything is on the moon. And you can see some of the features are pretty easy. There's like a boundary between a couple of the features. Of course, most everything on the near side, you have these very flat basins that you can identify and that are very large, so they go across pieces very well. But other parts of the moon are trickier. There's stuff on the far side that you just kind of have to know where it goes, and you have to kind of study the moon beforehand. So typically, I would just use like a 3D map of the moon, a colorized terrain map. So something that's got rainbow colors on it makes it a lot easier to see. You can do that through like Google Earth or things like that to find, to just compare what I'm seeing and where I can find these different features. But at this point, I've had to put enough of these together and solve it enough times that I know at least one identifying feature on every piece, basically. And that's not too hard to do. There's a lot of features on the moon. There's the Orientala Basin that's kind of across two parts there. Of course, most things on the near side, you can kind of remember, like, okay, here's these mountain ranges that go across the very center front of the near face. And the centerpieces, the core of the puzzle and the axes are aligned to the Earth-facing side of the moon. So this is the front, and then the kind of edges of the moon, and then there's caps. The center caps are on the North Pole and the South Pole and the center of the far side as well. So they are aligned to what you'd expect to see from the Earth. You can look at the front of the puzzle and say, okay, here's the near side that I'm solving, here's the far side that I'm solving, things like that. And that works out quite well. So since I've made the moon and I have this own method for generating the models, it means that I can generate an arbitrary planet. For any place that we have height data, I can generate a puzzle for it. And so I have done that. In fact, I've done it with the Earth. Sorry, that one's not solved right now. I've done it with Mars as well. Mars, this one is currently disassembled because I had I'm out of screws at the moment. And I've done with a few of other small bodies as well. But Mars was interesting because I had to do this variable terrain exaggeration to get it looking right. So if I can find the piece, Mars has a lot of really flat features and also really tall features. So it has these really big volcanoes on it, but then the rest of the planet that isn't the part with the volcanoes is just mostly really flat. So what I actually did was I made it so the high altitude terrain features are exaggerated less than low altitude ones. So that does mean that the Valles Marineris, for instance, is kind of way exaggerated quite a bit, but those more medium features, you can see them pretty well, while I've kind of preserved the sort of pancake shape of Olympus Mons and the other volcanoes. So I did this variable terrain exaggeration so that I could finally get a model of Mars that I really liked. Now, as far as making these maps myself, of course, this is Iapetus, and I tried out doing a multicolor, a bicolor print of Iapetus, and this turned out pretty well. So the way that I made these maps is just I can edit the terrain map in an image editing program like paint.net, and so that's what I did with this. Is I took the natural color map and adjusted it so that it was only two colors, so that it was only black and white, so that I would only have to print in these two colors. And but I had to do it in a way that would preserve the detail that I wanted so that it would be recognizable as the moon Iapetus. So you can look at it, and this, this orientation that I'm holding it in is a somewhat famous photo of Iapetus in this orientation from Cassini, of course. And so I wanted to preserve all that, enough detail as much as I could with just those two colors. And I did that, and it went pretty well. And I printed it in the two colors. You can see there's some areas that don't have data, and I just left those black in the image, which means they're the bottom of the height. And so as you can see, many of these places, I'm somewhat limited by the data that's available. So like I would love to do a cube of Pluto, but we got a really good look at one side of Pluto, and it is going to be a very long time before we see the other side in such detail. Earth was also an interesting puzzle to do because I did the combined above and below ground, below water terrain. So you can see part of the Earth kind of solved here. So you can see one of the continents, Australia, here, and that's above ground terrain, but also below the water, there's all this interesting stuff that's going on that I thought would be really cool to include. So I did that for the Earth puzzle. And so this is scrambled right now, so it doesn't look quite, it's probably a little hard to see what's going on, but I think this also turned out quite nicely. I also did I found this filament that is very close to the actual natural color of Earth's moon. So we have this very, very dark moon color, and it's a little bit harder to see some of the features, of course, because it is so much darker, but I think it's cool to have a moon that's close to its actual very, very dark color. That's probably very surprising to see if you've never seen a picture of the moon that's kind of adjusted for the sight of Earth as well, or any material from the moon that's brought back to Earth. There's also data for many small objects in the solar system. Small moons like Phobos and Deimos here. These two are not to scale. If they were, then the one in my left hand would be about, I don't know, 2 or 3 times as big as the one in my right. So that I decided to make these 2x2 cubes. I can basically do any combination of cube or puzzle and object, which is fun. And these ones I don't have to do any mapping or terrain exaggeration for. There's just, NASA has a library of online 3D models of these moons that you can just download. I also did Mimas. This one's not solved right now. I actually have to check the map of this one if I ever want to solve it, because these pieces are not really identifiable except by knowing the craters on them. But you can see the giant giant crater on one side, and you can also kind of see the oval shape of Mimas, which is not something I knew that it had until I was working on this puzzle. So that's kind of fun. I'd like to do not just Mimas and Iapetus, but many other moons of Saturn. Enceladus, I'm sure, would look really good, and it's got lots of little craters and very bumpy shape because it's so small. So lots of moons of Saturn that I'd like to do. This one I just completed. yesterday. It's Amalthea, and I gave it a red color because Amalthea is a very red colored moon of Jupiter. I don't know if it's actually this red, but it's known for having that color. And it's also known for this very long shape, so I made it a 2x2x3 puzzle, a tower cube, instead of a cubic puzzle, which is very fun. I kind of can tailor the shape of some of these smaller objects to make it a different cube. So what else would I like to do? Like I said, I maybe want to do some more planets. There's some other options there. Of course, Mercury and Venus come to mind. I haven't done those yet. I would like to... It would be cool to see if I could do like a full color Mars or something. But that's quite expensive to try out. And so I haven't gone and tried to do that yet. Although I am able to generate full color models. And of course, I can do these bicolor models with certain objects that works for. Like Iapetus has a very distinct white and dark side to it, so it really has those two distinct colors. Earth's moon also has kind of two distinct colors with the light gray and the dark gray, but I haven't... well, I tried to make a model of Earth's moon that was bicolor, like the Iapetus cube, and it didn't really work out well. It had some artifacts, and you can see to a lesser degree those artifacts here where there's some coloring around the edges. There are some lines across some of the pieces, and there's actually some parts, some chunks of the pieces that are just missing, that are not generated in the slicer, and that was more extreme on the Earth's moon, such that I was not able to print that. That was not printable. So I don't know why those issues are there. And I also don't really want to produce more of these multicolor cubes with the printers that are available to me right now, because I don't have any multi-nozzle printers, and the waste, the filament has to be purged every time you change from black to white or whatever. So it just ended up being really, it takes like double the amount of filament to make this cube than it would the same cube in one color. And I just don't really want to deal with that if I don't have a printer that can do it without all that purging. And even still, this puzzle, it feels way heavier, the bicolor one, than an equivalent single color puzzle, because there's so much just extra filament inside there because of the color swapping. So not something that I'll do more of just yet, but I did think it looked pretty nice. And if I can get rid of these color artifacts and get a printer that can actually do the color stuff efficiently sometime, I would be happy to keep working on stuff like that. The other thing is maybe, puzzles that are to scale somehow, like Phobos and Deimos. These two are not to scale. And while that might be cool, I don't really have any plans to do that, because you would just end up with some really big puzzles. Like, for instance, this moon cube is 80 millimeters across, a little more than 80. So if I wanted to do an Earth cube at this scale, it would just be like 320 millimeters or something crazy like that. So not really interested in having giant cubes like that. I already have enough giant cubes I'm hanging on to already. And of course, I came back to the Bennu model, and with my own mechanism, same as the moon cube. And because I use the same mechanism, this cube is actually a little bit bigger than the moon cube, and bigger than the original Bennu cube as well. And I really like this larger scale. It makes the rocks just so easy to see, and the pieces are really identifiable, whereas originally I had a really hard time solving this first one, and I had to be like scrutinizing the map and the pieces to figure out just barely where these little rocks were on the surface. This one here is just big enough, and I just recently added a little feature, which is just right on this spot here. There's a little bump that you're not going to find on the natural models of this asteroid, because that is my representation of the OSIRIS-REx spacecraft taking a sample right at the spot that it grabbed. So you can go and watch the video from the spacecraft of that, and you can find those features on the cube, which I thought was really fun. This cube is just big enough that you can see that on that. And I think this puzzle looks really, really nice with this asteroid model. I'm excited for the Apophis missions that are coming up as well, because I'll be able to do probably I could do some kind of puzzle of that, and I could even do a before and after of the Earth flyby, because it sounds like they're expecting some landslides to occur on Apophis, and I think that would be really fun to try and spot the difference there. But that's not going to be until 2029, so we've got a while to wait for them. As well as for the moons of Jupiter, I'd love to do like a Europa and Io and Ganymede and Callisto, but we just don't really, kind of surprisingly, we don't really have a lot of really good terrain height data that I've been able to find. It seems like there's kind of an unknown there, because most of the focus has been around orbiting around Jupiter and just occasionally flying by the moons, even those big ones. So I would be excited for that. And of course, there are a few more spacecraft that are on their way to Jupiter to study the moons. But again, they're not going to get there for a few years. I do have some ideas about what to do with Europa in the meantime, though, because I think I can maybe come up with something that looks pretty cool that's not based on terrain data alone. But I still have to do some work on that. And of course, if I wanted to do something like Jupiter doesn't really have terrain, but it does have those different colors. So I could make a map and like turn a color image into a grayscale of Jupiter and use that as a terrain map instead. So I could have kind of the bumps on a sphere like that. So lots of other potential things I could do with this idea. There are other puzzles I could make. I could try to do like a Megaminx or a Radiolarian or something with the moon. That would be pretty cool, because there's just so many craters. I think it would be fun to do a really, really hard puzzle with many pieces and many layers on the moon. Or maybe one of those other moons, maybe Callisto or like Mercury or something that have many, many craters, or even Enceladus. I am possibly somewhat limited in making a large puzzle by the resolution of the terrain that I do. I can take in a texture image, but because of my code, the only size image that I can actually take in is a 720p by 1440p image, and I'm not able to generate a 3D model based on any other image, because I haven't figured out how to do the triangulation of the pieces between the points, because the image pixels become the vertices of the model, and then you have to define which three vertices go together to form a triangle, and I haven't figured out how to do that correctly for an arbitrary image and size of the model, unfortunately. So maybe at some point I'll figure out how to do that. Maybe it doesn't really matter. The texture on this moon looks really great, and so maybe scaling it up wouldn't even matter so much. You can see, like on the Amalthea model, we don't really have that detailed terrain information for it, so it's kind of bumpy. It's got, you can see the facets on this 3D model, but it still looks pretty cool. So maybe that could be still pretty nice. And you can obviously find the identifying features, these large craters on this weird little moon that's almost getting torn apart in Jupiter's gravity there.